Perhaps nowhere else in our known world is there such a potential for discovery as there is in space. No matter how much we uncover, it seems that there is always more to be found. So today, here at Unexplained Mysteries, we will be looking at 3 recent space discoveries and what they mean for our understanding of the world around us. Scientists say around 7 interstellar objects pass through the inner solar system every year. Most people are familiar with the way the solar system works. Planets orbit around the Sun, drawn to its gravitational pull, and most of these planets have their own associated moons, likewise held in orbit around the planets. There are also objects flying through space that are not gravitationally bound to a star. These bodies, which include asteroids, comets, and rogue planets, are known as interstellar objects, and scientists have recently released data about just how many of these untethered flying objects might be zipping through the atmosphere at any given time. The first interstellar object in the solar system was detected surprisingly recently, on October 19th of 2017, and since then, scientists have been closely monitoring for signs of other objects entering our solar system. The results of these studies appear to verify theoretical work which suggested that these interstellar objects are not altogether uncommon within the solar system. In fact, a recent study conducted by researchers with the Initiative for Interstellar Studies determined that as many as 7 and possibly even more interstellar objects enter the Milky Way each year. Additionally, because these objects are formed outside the solar system and manage to make their way into our realm, it implies that there is an incredibly large population of these bodies being created throughout the universe. So why does it matter how many of these rogue objects find themselves flying through our solar system every year? The study revealed that, although these objects are only temporary nomads through the solar system, they tend to follow predictable orbits as they pass through. Knowing approximately how many interstellar objects we can expect in our vicinity every year, as well as having thorough data regarding the approximate paths that these objects tend to follow while passing through, opens up the possibility of potentially landing spacecraft on these objects one day. Although we have been able to study interstellar objects from afar, they are still largely a mysterious subject to researchers, and being able to study them up close and personal provides an unbelievable potential for knowledge for scientists seeking to study the beginnings of our universe and solar system. Additionally, because interstellar objects are formed in outside solar systems, being able to physically contact and study them would provide unbelievable opportunities for discovery regarding the conditions of other systems. This discovery, which has officially confirmed what we have long suspected, has revolutionized the field of astronomy. Marshall Eubanks, the lead author of the study and a physicist with the Initiative for Interstellar Studies, underlined the importance of this discovery in an email to Universe Today, saying that this discovery is significant in a way that cannot be understated. Just by proving that they exist, it has had a profound impact, creating a field of study almost from nothing, a field that funding authorities are just beginning to recognize. Interstellar objects provide us with the opportunity to study and in the future literally touch exobodies decades before the earliest possible missions to even the nearest stars, such as Proxima Centauri. Already dozens of grants have been proposed that would fund spacecraft missions to contact these interstellar objects, meaning that we might have answers sooner rather than later. Astrophysicist discovers numerous multiple star systems with exoplanets. The search for life outside of Earth is so relentless because there are so many possibilities beyond our own solar system. In fact, there are thousands of other stars besides our Sun with planets in orbit around it, including more than 4,000 exoplanets. This number greatly increases the odds of finding extraterrestrial life, and it seems that the number of exoplanets is only growing. Dr. Marcus Muggrauer, an astrophysicist with Friedrich Schiller University Jena, has recently discovered and characterized several previously unknown star systems containing exoplanets, and his published study has sent waves through the astronomical community. To obtain these results, Muggrauer searched through 1,300 host star systems in the search for hidden companion stars associated with the host star. He explained his process by saying, "Multiple star systems are very common in our Milky Way. If such systems include planets, they are of particular interest to astrophysics, because the planetary systems in them can differ from our solar system in fundamental ways." Essentially, Mugrawer was searching for the vicinity of thousands of already known host stars in the hopes that they would have an associated companion star that also had orbiting exoplanets. He used the Gaia Space Telescope operated by the European Space Agency in his search, which ultimately turned up fascinating results due to the precise data that he was able to collect. Mugrawer's search revealed the previously hidden existence of over 200 companion stars. The data that he collected allowed him to precisely categorize these new discoveries, which spanned a wide variety as to type and distance. Most of the companion stars varied considerably in their mass, temperature, and evolutionary stage, and some were located up to 1,600 light-years away from the Sun. The team also discovered that, although most of the study's star systems with associated exoplanets were two-star systems, there were a significant amount that were arranged in a hierarchical triple-star system, and even one that appeared to be a quadruple star system. The distance that these companion stars are from each other was also heavily studied, as they could tell us information about how planets are formed under different gravitational influences. They discovered that, of the distances investigated, 15% of stars have at least one companion star, which is a much lower frequency than expected. These companion stars are also up to 5 times further apart than normal systems. Mugrawer says, "These two factors taken together could indicate that the influence of several stars in a star system disrupts the process of planet formation as well as the further development of their orbits. In addition, we will combine the results with those of an international observational campaign, which we are currently conducting on the same topic at the Perennial Observatory of the European Southern Observatory in Chile. We will then be able to investigate the precise influence of stellar multiplicity on the formation and development of planets. One thing is for sure, this astonishing discovery is sure to lead to even more discoveries about the universe in the very near future." TRAPPIST-1 planets could hold more water than Earth's oceans. The star called TRAPPIST-1 is a close star, approximately 40 light-years away from our own solar system, and is one that is highly interesting to scientists due to the 7 planets, similar to Earth, that revolve around it. After careful study of the gravitational pull that these planets exert upon each other, researchers were able to present several theories about the composition of these planets, and some of them are downright mind-boggling. Some of the planets revolving TRAPPIST-1 could have up to 250 times the total amount of water contained in all of Earth's oceans. These calculations were made as a part of the constant search for signs of extraterrestrial life, or even indications that exoplanets could potentially support life, and TRAPPIST-1 is one of the best-known and most highly studied candidates outside of our own solar system. Elements of each planet in the system has been carefully studied, as the distance and their tight orbit makes direct observation incredibly difficult. Additionally, because they all orbit exceptionally close to each other, they frequently push and pull against the gravitational forces exerted as they pass neighboring planets in the system. Simon Grimm, leader of an international team of scientists with the Center for Space and Habitability, was one of the individuals who studied this phenomenon. He said in a statement, "In the TRAPPIST-1 system, the planets are so close together that they perturb each other. This causes a slight shift in the times of each transit. The team was then able to conduct simulations of these altered orbits and apply an algorithm in order to estimate the masses of each planet, which then allowed them to calculate individual densities and compositions. This is when they realized that the 5 lightest planets in the system could each have 250 times more water than the total amount in all of Earth's oceans. This means that water makes up about 5% of their total composition compared to the measly 0.02% of Earth. This information is groundbreaking to scientists hoping to study the potential for life outside of our own Earth, especially as 3 of the planets lie within TRAPPIST-1's so-called habitable zone. Bryce Olivier Demery, a professor at the Center for Space and Habitability and co-author of the recent study detailing these results, said, "We were able to measure precisely the density of exoplanets that are similar to Earth in terms of their size, mass, and irradiation, with an uncertainty of less than 10%, which is a first and decisive step in the characterization of potential habitability. But what do you make of these interesting discoveries? Be sure to let us know your thoughts in the comment section below, and please help us grow this community by liking and subscribing to our channel. Thank you for watching.